Good morning, madam. This is Suhail from Mechanical Department. Today I am here to present my CAS assignment 1 topic on Newton's rings. Newton's rings. Introduction to Newton's rings. Newton rings are a series of concentric circular fringes observed in optics. They are formed due to the interference of light wave reflected between two surfaces. This phenomenon is named after Sir Isaac Newton, who studied it in detail. Newton rings are circular bright and dark rings formed due to interference of light between a lens and a glass plate. They are named after Isaac Newton, who studied this effect. Historical background. New, Newton first investigated the phenomenon in the 17th century. His experiments involved thin air film between a plano convex lens and a flat glass plate. The study of those rings contributed to understanding light interference and wave optics. Newton discovered this ring in the 17th century while studying this thin air film. His work helped in understanding light interference and wave optics. Conditions for forma- formation. Monochromatic light is typically used to produce clear and distant ring. The surface involved must be smooth and parallel from uniform fringes. The observation is best made with a lens in contact with a flat glass plate. From clear rings, monochromatic light, single color is used. The lens and glass plate must be smooth, clear, and perfectly in contact. Experimental setup. A monochromatic light source which has a sodium vapor lamp is used. A plano-convex lens is placed over a flat glass plate to create the air film. The setup is illuminated and the fringes are observed through an IP, IPC or camera. A sodium lamp gives monochromatic light. A plano-convex lens is placed on a flat glass plate and the rings are seen through a microscope or camera. Applications Applications of Newton's rings. They are used to measure the wavelength of light with high preci- precision. Newton rings help in testing the flatness and parallelism of surfaces. The, the phenomenon is also utilized in the study of thin film and surface coatings. Newton rings help measure wavelength of light very accurately. They are also used for clicking flatness and quality of optics surfaces. Advantages and limitations. Newton's rings provide a simple method for optical measurements. They require monochromatic light and smooth surface for accurate results. External vibrations can distort the interference fringes. The method is simple and useful for optics measurements, but it need monochromatic light and perfect alignment. Vibration can disrupt the rings. Conclusion. Newton's rings are a fundamental demonstrator of wave interference in optics. The, they, they facilitate precise measurements and surface analysis in scientific and industrial applications. Understanding this phenomenon enhances our knowledge of light, behavior, and wave optics principles. Newton's rings shows how light wave interference with each other. They are important in scientific measurements and help us understanding wave behavior of light. Thank you, man.